Hi everyone, so welcome to iitiansgateclasses. So today I'm going to talk about various types of integrals, right, which will be utilized, which has a great application in electromagnetic. Okay, so today I'm going to talk about various, kind of integrals, right? Integrals. Okay, so let me various kinds of integrals. I'm gonna talk various types of integrals, which you might have studied in mathematics as well. So in this class, I will be confining to the mass vector calculus only, right? And we will also start electrostatic part where we will discuss about Coulomb's law and electric field, okay? And different kind of charge distribution such as line charge and uh, surface charge and volume charge, right? So to understand various kind of integrals, we'll take few problems, right? So we will discuss about line integrals, right? Uh, line integral, okay, where we'll calculate uh, uh, a dot dl, okay, the vector a will be given, right, dot dl is what the differential length, okay, over certain curve c, right? And we'll also discuss about surface integral, right, where double integral will be involved, okay, so you can say d dot ds, right, d dot ds, and the volume integral also will talk volume integral, right? So that is gonna be anything, okay, so we can say divergence of d dot dv, you can say, right? So this is going to be your volume integral, this is your surface, and this is your line integral, right? So let me take one problem which was asked in GATE 2011, I think, okay, so GATE problem, and we will understand from this problem. So the question says here is that if a vector is given here, a vector, right, a vector is given equal to x, y, okay, these are the component along ax, okay, direction, and x square in the direction of a by, okay, then what is the value of okay, then what is the value of, okay, what is the value of a dot dl, a dot dl. So they have asked what is the value of a dot dl over this curve c, right, contour over the path shown in the figure, right, over the path shown in the figure, right? So the figure given here is like this. So you can see this is a question, and the figure associated with this problem is like this, okay? So this is going to be your y-axis, and this is your x-axis, and there is a path given like this, okay? So in this direction, they have given like this kind of a path. So let me draw this, okay, along x-axis, okay, and they have also given the path along y-axis like this, okay. So this is a path given, this is your y-axis, right? So y-axis, and this is your x-axis, right? And they have also given, this path is from 1 by root 3, okay, x is changing from 1 by root 3 to 2 by root 3, right? So this is 1 by root 3 basically, 1 by root 3, and this is 2 by root 3. So this is going to be the limit when we will be in this path, right? You can say A to B, okay, and this is C, and this is gonna be D, right? So they have given by as well. So this is 1 and this is 3, right? This is 3. So let me erase this by from here and write on top of it, right? So this is a path given 1 by root 3, 2 by root 3, and this is okay. So we have to calculate this integral, okay, a dot dl over this path. So how I'm gonna proceed, right? So this is a closed path. I mean, we have to move from A to B, right, and B to C, and this is gonna be your open surface, you can say, right? So let me solve here, right? Solution. So as I said that there is a vector and a dot dl. Whenever you are in the x direction, right? So what shall be the dl? Dl is gonna be your dx, right? Dl will be basically dl will be what? Dx ax cap, right? And when you will be in the by okay direct axis or by direction, when you will go from B to C, so your dl will be basically d by a by, okay, this is the differential length already we have seen, right? Okay, so now what we can do here is we have to calculate a dot dl, right? So we have to we have to consider here the line integral as circulation, right? We have to move around this path from A to B, from B to C, from C to D, and from D to A, right? So what are the integral we are going to get, right? So this is going to be from A to B, one path is there, plus B to C, plus C to D, okay, and plus D to A. Okay, so there is a trick, right? If you're moving from A to B, right, so you have to take the limit of this dx, right? This dx, from 1 by root 3 to 2 by root 3, right? And the vector, once you will take the dot product, a vector dot dl vector, right? So this ax dot ax will give you unity, and this by in the direction by the by component is gonna be 0, right? You can say that just moving, okay, moving along this like this. So we are moving from A to B and then C to D, okay, then D to A, okay. So just we are moving, so we can say that this is going to be 1 by root 3, so 2 by root 3, right? And what is the component here? The component along AX is x by, right? So you can say x by, okay, x by, that is going to be your dx plus then you are moving from B to C, right? So when you are moving from B to C, 1 to 3, there is a limit 1 to 3 here, right? And you have to take the component along axis, along by axis only. So this is and you have to integrate with respect to by plus. Then when you are moving from C to D, right? So C to D, C to D means you are in the x direction only, right? And limit, now this time limit you have to take from 2 by root 3 to 1 by root 3, right? Okay, so this is going to be 2 by root 3 to 1 by root 3, right? Okay, so let me change the color here. That is going to be 1 by root 3, okay, root 3. And this is going to be your x component only, that is x by. So this is x by and dx, right, plus. Now you are moving from 1 to you can see here you are moving from 3 to 1 d to a, right? So limit of integration is going to be 3 to 1, right? And this time you have to take x square d by, okay. So you can see whenever you are moving from from A to B, right? So what is constant here? The constant is by, and that is by equal to 1, right? By equal to 1 in when you are in the path A to B. So here the by is equal to 1, right? And when you are moving from B to C, so x is equal to what? X is equal to constant, that is you can see here when you are moving from this, so x is constant, that is 2 by root 3, right? So 2 by root 3, these things you have to keep in mind, okay. 2 by root 3. Okay, to explain you I'm writing all these things, otherwise you can get the answer in one line, right? So in place of by you can place 1 here, right? In place of x you can place 2 by root 3. In place of again by you can place 3 here, and in place of this you can place 1 by root 3, right? So this will be constant here, so 1 by root 3 you can place, okay, in place of x. So let me write in a different okay, so let me substitute all the values. So next step is gonna be like this. Okay, so you have to see which is constant, right? So now here let me tell you that here by equal to 1, so and in integration of x is that you know, that will be x square by, okay, x square by 2, okay, from 1 by root 3 to 2 by root 3, right? Okay, then plus you can see here this is 2 by root 3, right? And you have to square of that, the 4 by 3. Okay, here we can directly write 4 by 3. Okay, and uh, now the constant inside the integral, there is a constant, right? So you can say 3 minus 1, that is 2, right? Plus here you have to put you know, in place of by equal to 3 here, right, when you are moving from C to D. So and this is going to be x square, right? So again you can say this is x square by 2, and your limit of integration is from lower limit 2 by root 3 to 1 by root 3, right? Okay, and the by equal to what? By equal to, they have given already, that is 3 plus. Okay, now here again 1 by root 3 squares 1 by 3 and 1 minus 3. Okay, so this is going to be your integral. Now once you will place upper limit and lower limit, right, and try to solve this, okay, you're going to get here like 1 by 2 and 4 by 3 minus 1 by 3, right, plus 4 by 3 calculated, and 2 by 3 by 2, okay, 3 by 2, 1 by see here, and here is you will get 1. Okay, you will get 1 as the answer to the question, right? So this was very easy question. As you can see here, 4 by 3 and 4 by 3 and 1 by 3 in this case, right? Okay, so I hope it was not there. 3 by 3, mm, 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 so this will be 1, and this is gonna be giving you. So let me keep everything I've taken out. Once you will solve this, will be giving this. This will have to calculate uh, integrals, right? Line. Okay. So what we have done here is the one given. If you have been given the path, so your job become very simple just to find the answer, right? So what you have to do is whenever you are a long axis, so take is going to hamper you then. Okay. So you can see here this conclusion we can make from here is, okay, if you are computing this and it becomes zero, right? If this kind of field is conservative. So if they will ask from this question, they can ask that whether this field is conservative or not. Field, okay, this field conservative. Okay, line integral over loop. Okay, over a closed loop is not zero, right? Not zero. Okay, so you have to keep this in mind. Then, let me take one more problem. Okay, this time the vector given in is in uh, the cylindrical coordinate. So you can see a vector is given. A vector is given as 2, rho square cos phi, and a rho cap plus rho to the power 4 by 2 a phi cap, right? Okay. Then calculate a dot dl, right? Then calculate a dot dl, a dot dl. Okay, over certain path they have given. Okay, so let me draw that path as well. So the path given here is like this. Okay, this kind of path they have given, right? So you can see the radius of this is a, and there is a contour c1. Over c1 you have to compute, right? Okay, right. So what you have to do here is the contour c1 is given in xy plane. Remember, contour c1 is given in xy plane. So you can add this line as well. Contour c1 is given in xy plane. If it is given in xy plane, then z shall be 0. Okay, that's why here in fact in a vector, okay, there is no z component, right? There is a rho, phi and z, right? But z component is going to be 0 because the contour c1 is located on the xy plane, right? So let me compute a dot dl here. So the solution is going to be like this. So again, the component and along which you are moving, okay, you have to take that component, right? So a dot dl. So what is the differential length in case of cylindrical coordinate system? That is d rho, a rho cap plus rho d phi, okay, a phi cap, okay, plus dz az cap, right? So it will be directly 0. You can say this is gonna be your 0 because z component is 0, right? I mean, in the question itself it is not given and you are in the xy plane, right? Okay. Now what we have to do here is you can see here when you will compute what a dot dl, a dot dl, right? So when you are computing a dot dl, so in case of row component here, in case of row component, only which component is given? See, your row is constant here. In this contour, you can see your row. This is constant. Row is going to be constant, right? So what is varying? The varying is only phi, right? You can say this is phi. So phi is varying. And what is the limit of phi? As we know that limit of phi is 0 to 2 pi, right? The limit of phi is 0 to pi. So you can see here, when the rho is constant, then d rho component will be what? This guy will also be 0, right? This guy will also be 0 only, right? Okay. So now you have to find the A dot dl along C when phi is varying. So you can say phi is varying from 0 to 2 pi. And which is the phi component? You can see phi component is this. Okay, that is um, rho to the power 4 by 2. Okay, and this has to be multiplied, right? So this is rho d phi. Okay, so this is going to be simple, right? So you can see here, now in place of rho you can keep what? You can keep a. So this is a to the power 5 upon 2, and phi will be varying. So what is the answer here? You got pi a to the power 5 is the answer for this question, right? Because rho is constant over this integral inside this integral, so you can take this guy common. Okay, and the answer will be pi a to the power 5. Okay, I hope this is clear for everyone. See, the contour will be given in your question, and they will ask you calculate this line integral over this contour, right? So you have to see in the differential component, okay, which differential component you have to consider. D rho will be 0 because rho is gonna be constant, and what is rho? Rho is a, right? So the if you will differentiate the constant one, right, so it is going to give you 0 only, right? I hope this is clear for everyone. So this was very good question. Okay, and one more question, let me okay give you. Okay, so the calculate the line, calculate the circulation of a vector. This time they did not mention line integral, right? So we are talking about line integral as circulation, right? Line integral as circulation. Okay, so if you are able to solve this kind of problem, so in the gate or in HAL, in IES, any kind of problem you can solve, right? So calculate the circulation of a vector. Calculate circulation of a vector A. This time A is given as rho cos phi in the direction A rho cap, right? And they haven't given what in the phi direction. They have given z sine phi in the z direction, right? So here the phi component is missing. So integral over phi will be 0, right? So remember that, okay? Right. Around the edge L, okay? Around, let me finish the question first, then we will start solving. So this A is given. We have to calculate what? Circulation of vector A, okay? Around the edge, around the edge L of the wedge defined by, of the wedge. One wedge is given here, right? Wedge defined by, okay? Defined by, here the limit they have given here is, your rho is varying from 0 to 2, okay? 0 to 2, right? And your phi is varying from 0 to 60, okay? And your z is basically 0, okay? Okay, because they have given this edge L of a wedge, okay, in the xy plane. You can say xy plane. In the question they can mention this as well. So z is gonna be 0, right? So along z you don't have to compute anything, right? Okay. And the contour they have given, this edge L they have given like this. So let me draw that as well. So okay, so let me take this line here so that line will be okay. This kind of a thing they have mentioned. Okay, so here to here and here to here, this is rho. Okay, and this is you can say this is O, and this is O to P, and this is Q, and this is 60°. Okay, so you can see this is x-axis and this is y-axis, right? So in x and y plane, they have given this kind of a edge of L of a wedge, right? Okay, so if you're along rho, right? If you're along x-axis means you are along rho, right? So you have to consider this component, rho component only, right? And integrate. Okay, you have to compute this. You have to consider this. And what is the phi value? Phi is going to be 0, right? You can see here when you are starting, this is the phi value, and along x the phi is gonna be 0. This is phi. Already we have seen this kind of a thing, right? This is rho, okay, and this is phi from x-axis. Phi is measured from x-axis, okay? Phi is always measured from x-axis. Remember, phi is always measured from x-axis, okay? Phi is always measured from x-axis. This. What you can do here is you can directly compute the integral. So what we are going to do here is uh, let me take in a different page, right? This we have to take what? We have to consider this. Okay, so a vector we have to write and directly integrate, right? So let me go to next page. What a is given here is that a was given as rho cos phi, rho cos phi, and a rho cap plus z sin phi, a z cap. Okay, so now let us compute a dot dl, right? A dot dl. So a dot dl can be computed like this, and dl already I have told you that dl is going to be what? Your dl will be equal to uh, d rho a rho cap plus dz az cap, right? Because they have given or you can say also rho d phi a phi cap. This is a rdl. Okay, so when we are in from o to p, you can say from o to p, integration from o to p plus integration from P to Q, right? And integration from Q to O, right? Three integral you have to compute. So when you are in O to P, the phi is going to be 0. In this case, the phi is 0, right? When you are in P to Q, right? So phi is going to be 60, okay? And when you are in from Q to O, okay, so again you can see the phi is going to be 60 only, right? So when we are in O to P, so your rho is varying from 0 to 2, okay, and rho cos 0 means 1, so rho d rho plus along phi there is no phi component, no phi component is given, right? No phi component is given, right? So the second integral by default is 0, right? So this is going to be 0 plus. Now you have to move from 2 to 0, right? After all, rho is varying from this. So you can see this is the wedge, right? And here the rho value is 2 and 2 here only, right? Because this rho is a radius, you can say. Okay, right. So let me write here, and now you are moving along rho, and the phi is 60. So what is cos 60? That is 1 by 2. So rho by 2, and here it will be d rho, right? So you can solve this integral. This is very easy integral. So what you will get here is that 1 by 2, and you will get 4 plus 1 by 4 into minus 4, right? So what you are getting here is 2 minus 1, that is 1. Okay, so this was very easy again. So my suggestion would be, whenever you solve this kind of an integral, right? A dot dl, and if the path is given, so you know, when you are in certain path, when you are moving along certain path, so take that component, consider that component only, and angles and everything you have to take care of, right? So remember that the phi is measured, phi is measured, this phi will be measured, right, from the x-axis always, if we recall cylindrical coordinate system, right? Phi will be measured from x-axis. Right? This is x-axis and this y, this is z. If you know this, you can solve any kind of questions. Okay. Now, okay, so I hope this is clear for everyone. Let me take one more problem and then we will go for divergence theorem and Stokes theorem, right? So the problem stage here is that you use cylindrical coordinate, cylindrical coordinate system, right? Use cylindrical coordinate system. Uh, 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 area of a area of a surface, right? Circular okay, having radius equal to 3 meter, equal to 3 meter. Height they have given here is 6 meter. Okay, 6 meter, and phi is varying from 120 to 60, and phi is 120 degree to vertical coordinate system to find out area of a curved surface on a right surface and having radius meter and height 6 meter, and phi is varying from 120 to 60, right? So what you have to compute here is that you have to compute the area of a curved surface, right? So what is area of the curved surface? Area, you need to find the ds. See, you need to know ds, right? So ds will be what? Ds will be whenever the rho is constant, right? Rho is constant. If the radius is constant, it will be rho d phi dz, a rho cap, right? This will be the differential area, right? Because the rho is constant, means you have got three lengths, right? So one length is d rho, second length is rho d phi, and third length is dz. If the rho is constant, so this d rho is going to be 0. So you have to take the product of this, right? Okay, so this is going to be helpful for uh, computing curved surface area. So CSA will be CSA, that is curved surface area, will be from your double integral, right? ds. What is ds here? You can say rho d phi and dz. Okay, so height should vary from 0 to 0 to 6, and your phi is varying from 120 to 60, right? 120 to 60 degree. And what is rho here? Rho is given as 3, right? So you can say this is 3. So now it will be 3, and if you will take the if you will take the difference between this, okay, this is 60, that is uh, okay, that is pi by 3, and this is 120, right? So you can compute this. So you'll get here After all, 60 minus 120, that is minus 60, and minus 60 means minus pi by 3. Okay, and this is 6. Okay, because after all this is constant, so I mean 1 is there, 1 dot dz. Okay, that will give you z only, and then you can put the limit. It will be very easy integral. I think everyone can do. Okay, so this will give you answer as minus 6 pi, and the direction will be this. Okay, after all this is area, right? So area will be having the magnitude, right, and this direction, that is a rho cap. Okay, so I hope this is clear for everyone. Next question is gonna be your very good question again. If the volume charge density in a spherical coordinate system, if the volume charge density, okay, so this year in the gate 2022, right, one question was there involving a surface integral only, or so we will see that question. Okay, so that question we can do in 30 seconds. Okay, so it was for 2 marks, I think. So we will solve that question. So if the volume charge density, okay, if the volume charge density in a spherical coordinate system, in spherical coordinate system, okay, in a spherical coordinate system, if the volume charge density in a spherical coordinate system, right, is given by, okay, you don't know about volume charge density, no problem. Okay, that is denoted by rho v, right? You have to keep this in mind. We will talk about that when we will start discussing about electrostatic. If the volume charge density in a spherical coordinate system is given by, that is given as rho v as a function of r theta phi. Okay, these are the parameter of spherical coordinate system. That is given as rho naught, okay, upon r, okay, Coulomb per meter cube. Okay, so if you see the problem set from W.H. Hayat, right, the book, one of the very good book is the W.H. Hayat. Okay, so if you will refer, so you will find this kind of problem, right? So if the volume charge density in a spherical coordinate system is given by rho v, that is rho naught by r Coulomb per meter cube, okay, which is centered at the origin, right? Which is centered at the origin, okay, centered at origin. These problem looks scary, but they are very easy, right? So centered at origin. So what you have to calculate? You have to calculate the total charge in a sphere. You have to calculate, okay, calculate the total charge. Total charge in a sphere, okay, in a sphere of radius a. Okay, what you have to compute? You have to compute total charge in a sphere of a radius a, right? So let us talk about I mean, just I want to discuss here is that if your differential charge is what, rho v dv, right, rho v dv. Okay, suppose this is a differential charge. You know that rho v is the volume charge density, and if you are going to multiply with dv, so it becomes charge, right? So you can integrate, so you will get q equal to what, q equal to triple integral rho v and dv, right, rho v dv. And you must know that this you have to compute. Okay, this you have to compute. Okay, this you have to compute. So rho b is given, as rho naught by r. Okay, and you must know what is the differential volume in case of a spherical coordinate system, right? So the dv is basically r square sine theta d theta dr d theta d phi. This is the rho v. Okay, and if theta range is not given, so theta range will be from 0 to pi, and if phi range is not given, so you can consider from 0 to 2 pi. Okay, already we have discussed these things in so now what you can do, you can place this dv here, right, this dv inside this integral. So this q can be computed like this. Q will be equal to triple integral, so you can say 0 to 2 pi and 0 to pi, and your r is ranging from 0 to a. Okay, and rho v is given as rho naught by r, and this dv is given as what? Dv was r square sine theta dr d theta d phi. Already we have discussed these things in the couple of classes. So here you can say r square sine theta dr d theta d phi. Okay, so cautiously if you do this integral, right, so r and r get cancelled, and sine theta integral will be, you know, minus cos theta. Minus cos theta will give you 2. Okay, because if you will place 0 to pi, it will give you 2, right? So you'll get 2 pi. Okay, you will get what? 2 pi rho naught times a square will be the answer for this question, right? So this is going to be your, okay, if a is known, if rho naught is known, then you can compute numerically as well, right? So I hope this is clear. So these are the application of line integral, as I discussed, right? The surface integral and the volume integral. Okay, so there is no theorem we have applied, but now suppose you have to compute line integral, but calculation of line integral becomes tough. Okay, so that question can be done by considering some surface, right? So what you can do here is you can use certain theorems. So there are theorems which are very important to convert line integral to the surface integral, or surface integral to the volume integral, right? Which will be helpful to solve the problem. Okay, in very because this time in the gate examination question was there, right? So we'll solve those questions as well. So divergence theorem and the Stokes theorem. So what is divergence theorem? Okay, this is very important. Divergence theorem. And we will discuss also the Stokes theorem after that. Okay, divergence already we know, that is del dot d. Okay, or del of a vector, right? Divergence of any vector. So divergence theorem says that what? It converts surface integral to the volume integral. So the very easy definition is, you have to keep in mind, converts surface integral. Okay, surface integral to the volume integral. Okay, volume integral. It is very easy. Okay, so if you have been given, if you have been asked to compute surface integral, so you can find that you can compute with the help of volume integral as well, right? Okay, so according to this theorem, these quotes you have to keep in mind. Okay, these lines, according to this guy, it says that, okay, according to this theorem, right? Okay, according to this the volume integral of divergence of a, right? Volume integral of divergence of a means divergence of a vector is equal to, right, the surface integral of a, surface integral of a, okay, taken over any surface, taken over any surface, taken over any surface. So it converts surface integral to volume integral. First point you have to keep in mind, divergence theorem I'm talking about. And according to this theorem, uh, integral of volume integral of this, that is divergence of, means you have to compute divergence of a vector will be given. You have to compute divergence of A, and if the divergence of A is 0, right, then answer will be 0, right, because overall volume integral will be 0, right. So sometimes it happens that the field given is the solenoidal field, okay. So solenoidal field means what? The divergence of A is equal to 0, okay. So this is what the divergence theorem says, okay. So if I talk about mathematically what is divergence theorem, so mathematically, okay, mathematically divergence theorem is written as A dot ds, okay, over a closed surface A dot ds converts, okay, to the volume, that is del dot A times dv, okay, over the volume V, okay. So you can see here this is the divergence theorem. So what we are doing here is we are converting the surface to the volume, right, surface to the volume, and direction of ds is always what kind of what will be direction of ds? After all, we are in the closed surface, right? This is a closed surface. So for the closed surface, the direction will be always outward normal, right? Direction for the closed surface, you can keep here note. For the closed surface, the direction of little ds, right, of differential surface, direction of ds is always outward, right, outward. Keep this in mind. Outward normal, okay. So for the closed surface, the direction of ds is always outward normal, right. Suppose you take one football, right, this is a football kind of a thing, right. So you can't get inside the football now, so you will have to take the direction always outward normal, right, always outward normal, wherever you go, any point you go, always outward normal, okay. So for the closed surface, this is the concept, and for open surface it will be always normal, okay, always normal. So this theorem is applied to any volume which is bounded by the surfaces, that you have to keep in mind. And what Stokes theorem says that Stokes theorem what Stokes theorem says that the Stokes theorem says that states that the surface integral of a curve, surface integral of a curve of a curl, right, of a vector field over an open surface, an open surface, this is very important, open surface, over an open surface, this R open surface is equal to the line integral of a vector field, line integral of, of a vector field, vector field over the closed over a closed surface, or close, I can say, close through the surface area, through the surface area, right. of a curl vector field over a closed surface is equal to, you can say, the line integral of a vector field over the closed surface bounded or bounding through the surface area. You can say written here open surface, okay, and inside the open surface integral there will be curl, right, curl of ds, vector, okay, is equal to the closed line integral, right, closed line integral a dot dl. This is the line integral as circulation, right? So this is the Stokes. Okay, so remember this is a open surface. Okay, this is very important because sometimes in the examination they have mentioned in the options, they have mentioned in the options what they have mentioned in, ask you to identify which option is only. So the big problem. Okay, so these problem can be asked directly in public sector or in HAL exam, ISRO exams, right? So a vector field V is a vector field V a vector, right? Here, this is a V. A by a relation y by a relation V equal to, they have given V equal to what? Curl of A. Statement is which of following statement is correct. So whenever curl is there, so will be the Stokes theorem, right? It will be the Stokes theorem. So what will be the Stokes theorem here in using this case? So del cross A, that is you can say V dot D. Okay, close integral A dot dl, right? A dot, this can be the possible answer. In the question they have also mentioned C, okay, specifically C and S sub C, right? C and S sub C refers to any closed surface contour and space whose boundary is C, right? Whose boundary is C, remember, refers to refers to any closed contour, any closed contour, any closed contour, okay, and surface and surface whose boundary is C, whose boundary, right? Okay, a vector V is related to another vector field A by a relation V equal to A cross del cross A, then which of the following statement is correct, right? So the option first is given. This question was asked in 2011. Okay, so A, this is this kind of the V as C, right? C A dot ds. Okay. Option B they have given here is control C and curl of vector V dot dl equal to, okay, so this option will not be correct, right? This option, or let us see which option is going to be correct, right? So A dot del cross A dot ds, and option C is given as C uh, curl of A dot dl is equal to as C ds. Okay, so this is given in the question, and option D is given as A dot dl is equal to as C V dot ds. Okay, so from the from the Stokes theorem, right? From the Stokes theorem solution, what is Stokes theorem says that what is Stokes theorem says here is that the open surface, right, uh, having curl of that is the closed and over closed contour, you can say. So in case of divergence theorem, there was no line integral. We have done problem as well. So this you know it's related with V vector, right? So you can replace this with V vector, right? So this is V dot ds equal to A dot dl. Okay, so which option is going to be correct? You have to decide now, right? So the option, I think option this is over C and this is C, right? So option C is option D. D is gonna be correct, right? This is correct, right? So this can be replaced by curl of A. That should be having the curl with that, right? That you have find with another vector V. So this is going to, so option D will be correct. So this kind of problem can be asked in the examination. So you have to keep this in mind. The open surface should be there, right? Open surface. Okay, and this should be the closed contour, right? Or over a closed line, you can say, right? So please keep this in mind. And Stokes theorem is used to convert to Stokes theorem. These are the tricks. Okay. Stokes theorem converts what? Open surface to closed line, right? Line. So you can remember. Okay, and divergence theorem is what? The closed surface to the volume, right? Closed uh, surface integral to what? The volume integral. I hope this is clear for everyone. The Stokes theorem and the divergence theorem, right? So one of the question let me take here is that very important. Consider field A. Consider vector field A then closed, they have mentioned here closed loop line integral means you have to find, I mean, called Stokes theorem, right? So this is line integral. Okay, so consider a vector field A, then closed loop line integral uh, a dot d a dot dl, right? This is a vector here, uh, L can be expressed as, can be expressed Stokes for understanding, not just to mug up the formula, mug up that expression, and so you can easily solve this kind of a question in a second, right? So in the options, you can directly answer. See, they have given that the you have to compute this, right? The line integral. So we open surface curl of A, right? Curl of A ds. So in the options, wherever you will find open surface, right? Wherever you will find open surface, that is going to be answer. Okay, so let me write here the options. So the options here say option A is given. Okay, option A is basically they have given the closed surface, right? Curl of A vector. Right? So directly it is wrong, right? Over the closed surface, over the closed surface. The word closed surface puts this option out of the answer, right? So element you can surface bounded by the loop, bounded by loop, and option B is given as what? The closed surface divergence. And this is out because in case of Stokes theorem there is no divergence involved, right? There is a curl involved. So this is the divergence of a dV over the closed surface, over the closed surface bounded by loop. Okay, and option C is that they are given open surface curl of A dot ds, and here they have mentioned over the open surface, or the open, okay, over the open surface bounded by the loop, you can say bounded by the loop. And the last option is that is D option, you can say, is given as uh, triple integral A dot divergence of A vector dV, okay, over open volume, right? Over open volume bounded by the loop, bounded by loop, right? So which option is going to be correct for this question? So option C will be correct here, because this is only the answer, open surface. Okay, so please keep recall that, always recall Stokes theorem, right? I hope this is clear for everyone, right? One more question let me take here, based on divergence theorem. So these two questions were asked from Stokes theorem. So in the HAL they might ask for one, for quick, in the MCQ, right? Okay. Consider closed surface S. Consider the closed surface S, right? Consider the closed surface S surrounding a volume V, surrounding a volume V, right? Surrounding a volume V, okay? If R vector is the position vector, is a position vector of a point inside the surfaces, inside the surfaces with and cap as unit vector normal, as unit vector normal, okay, to the surface, then what is the value of, then what is the value of, okay, then what is the value of integral? They have asked integral here, right? Integral, they have given the integral here, that is this 5 r vector dot n cap ds. So you have to find the value of this, okay, and they have given some options as well, right? So you can go through the question again. The consider the closed surface as surrounding a volume V if R is a position vector, R vector is a position vector, right? What is R vector here? Solution. So they have given the closed surface here, right? And you can compute this closed surface with the help of, okay, so this ds into n cap can be written as ds vector, right? Because ds here is what? Here the ds is the magnitude, right? And this is the normal, right? Because the area is a vector quantity, right? The differential area is also the vector here, and n cap is the direction they have given, okay? So we know that from the double integral a dot ds can be computed with the help of volume integral, right? Volume integral divergence of a dot dv, right? What is a here, right? So in this integral you can see here, recognizing the fact that this guy is what? This guy is basically the ds vector, and this is a vector, right? You can say a vector, and this 5 is a constant, so you can take outside. So 5 is a constant we have taken outside, right? And volume integral divergence of r position r vector and dv you can say that is dv only, right? It's okay. But now what is divergence of position vector? So r vector is what? R vector is x ax cap by ay cap z az cap. This is the position vector, right? So divergence of r will be what? 1 plus 1 plus 1, that is 3. Because you will take the partial derivative with respect to x for the x component, for the y component, for the z component, right? So you'll get here 5, and this will be again constant, so you can say 5 by 3, and this will give you volume. So you can say that this is 15 and v, capital V is the volume. So this is gonna be your answer. So how easy this question is? So you need to understand what is the meaning of this. What is the meaning of uh, ds n cap, right? Ds n cap is basically ds vector, okay? And the moment you see the question, you must be able to realize which concept we are going to apply, right? I mean, okay, so that you can solve any kind of questions. So let me take one more problem, right? Very good problem, in fact, which can be asked in your examination, is that if a field is solenoidal, if the field is solenoidal, if the field is solenoidal, then option A, option B, option C, and option D. Option A says that the field is solenoidal. It does not mean that it will be conservative, right? If the field is solenoidal means what? The divergence of any vector A will be equal to 0. Understand? Solenoidal means divergence of that vector is 0. If the divergence of that vector is 0 means what? The closed surface integral will be equal to 0, right? The closed surface integral will be equal to 0. Okay, remember, you don't have to recall the Stokes theorem. Okay, if the solenoidal is 0, sorry, if the field is solenoidal, then you have to recall what? You have to recall the divergence theorem, right? So if the field is solenoidal, then the closed line integral, right? V dot dl is equal to 0, and the closed surface integral v dot ds equal to 0. Okay, and v dot ds equal to 0 without any integral here, and the curl of b does not equal to 0, right? So if the field is solenoidal means divergence will be 0. Divergence of a vector is 0, right? So divergence of a vector where it is involved, right? So you have to keep this in mind that if the b dot ds equal to what? From the divergence theorem, divergence of b dot dv. So if this guy is 0, if this guy is 0, right? Divergence is 0 because the field is solenoidal. So this is gonna be 0, right? This will be 0. So which option is gonna be correct here? So option B is going to be correct. This cannot be, this cannot be, and this cannot. Okay. If the field is conservative, then option A will be correct, right? If the field is conservative, then option A will be correct. But in case, okay, in this case, the option B is going to be correct. I hope this is clear. So this kind of a question you can expect from vector calculus, right? This kind of a question you can expect from vector calculus, right? I hope for everyone everything is clear. One more very beautiful problem let me solve, then we will start the electrostatic, because these sessions are purely the theory followed by great problems, okay, so that you could understand the theory, right? So always whenever I discuss some theory, then I followed by the question, I always take, right? So the question says it is that if the vector f, okay, if the vector f is given here, that is z ax cap plus x ay cap plus y az cap, right? And S represents the portion of a sphere, and S represents the portion of F. Okay, portion of sphere, right? Not F, sphere. Okay, sphere x square plus y square plus z square equal to 1. For z is greater than or equal to 0, right? Then what is the value of, then what is the value of then what is the value of open surface, that is curl of f, right? That is curl of f ds. Very good problem, right? So this kind of problem can be asked. It looks purely mathematics, okay, mathematical, but yes, it looks like it is asked from the mathematics. Yeah, it is true, because if you're not good at maths, so you can't solve electromagnetic problems, right? So if f vector is given and S is here represent the portion of the sphere, that is x square plus y square plus z square equal to 1, for z is greater than or equal to 0, right? So here the z, if I'm gonna consider ds, so z component will be there, right? Ax, okay, the surface differential surface will be what? Dx and dy, dx into dy az cap, right? Then what is the value of that? So it looks very easy. You can compute this curl of this. So using determinant, you can compute the curl of that. So what is curl of that? So curl of f. First of all, we need to calculate this first step. Okay. So the curl of f can be computed ax cap, ay cap, az cap, right? Here x dash, y dash, z dash, partial derivative, remember. So if I'm gonna compute for ax component, so it will be giving you 1 plus ay component, it will giving you 1 current. Now, so here you have got x cap plus ay cap plus az cap. Okay, this is define ds. What is ds vector? Ds will be dx dy az cap. And what is curl of f dot ds? So here you can multiply ax cap, ay cap, az cap, right, into dx means x square plus y square. So what circle, and what is circle is pi r square, right? So what is r here? R is 1. You can say this is pi. Okay, so the answer for this question is pi, right? It is very easy question. Okay, as I showed. So I hope this is clear for everyone. Now let us start the topic which is very very important, that is electrostatic. Okay, so in electrostatic, we need to study first the charge configurations, right? Because without charge configuration, we can't talk about Coulomb's law and all, right? Because to discuss Coulomb's law, we need point charges, okay? So electrostatic means what? Already you might have studied in your school days, right? When electrons not in motion, right? When the velocity is zero, right? When the electron is at rest, right? The charge is at rest. Charge is at rest. What is the meaning of rest? The velocity is equal to zero, right? All these things you know, okay? So I need not to talk again. But before talking about Coulomb's law, before talking about Gauss law, right? Already we have covered all the basics, in the vector calculus, in the coordinates, coordinate systems, and also how to compute double integral, triple integral, surface integral, line integral, right? Everything you must be, able to now recall and solve the problems, right? So try PYQs, right? PYQ of gate and ESC. In fact, in the mock examination, we will be providing many questions, so you can try. Okay. So let us talk about charge configurations. Charge uh, configuration right now. We need to understand, what are the charge configuration we have, right? And they will also help you to discuss. So we will be having, charges, at at one point only, all, charge will be concentrated. So that point, that charge will be known as point charge, right? Point charge. Okay, that point charge, a charge confined to a point, remember, a charge confined to a point is known as point charge. And there will be charge distribution, right? If charge is distributed along the line, that is going to be line charge, right? So the charge distribution will be there, charge distribution. Okay, charge distribution in line, over the line, over the surface, and the volume, right? So in charge distribution, actually we are going to see three kind of okay, so here charge distribution, we will see line charges, okay, and the surface charge, okay, and the volume charge. Okay, so these are the prerequisite again. When we start talking about electrostatic, talking about Coulomb's law, right? The force between two charge, which the charge which will be at rest. Okay, and we'll talk about electric field, and then Gauss law, how to compute electric field using Gauss law and all, many things, and flux. Okay, electric field lines and all we will discuss. So point charges means the charge which will be confined to a point is known as point charge, and the charge distribution means charge which charge, suppose charge is distributed along the line, that is line charge, surface, and volume. Okay, and surface charge can be, these charges can be uniform or non-uniform, right? So these things are also you have to keep in mind, uniform and non-uniform. Okay, so let me define point. What is point charge? What is point charge? The charge confined to a point. The charge confined to a point, right, is known as point charge. Okay, a charge which is confined to a point, matlab the moment this, suppose this is a point, here is the charge q. So this is point charge, right? This kind of a thing, this kind of a representation we do. So a point charge means what? The charge confined to a point is called the point charge. Okay. Okay, in general, charge has a dimension. What? Charge has dimension Coulomb. Okay, remember these things, right? And if I talk about line charge, okay, line charge, rho L, okay, line charge means rho L, okay, line charge density, line charge means Q only, but the line rho L will be the line charge density, okay. So if line charge density is given, that is rho L is given, how to compute Q total charge, right? We will talk about that, right? The distribution of charge per unit length is the line charge density, remember. Distribution of charges, right? Charge, distribution of charge per unit length, okay, is called the, is called line charge density. Remember, line charge density, okay, which is represented by rho L, okay, rho L, Coulomb per meter. Suppose this is a line, okay, this is a line, and here the charges are distributed along the line. The charge will be rho L, that is Coulomb per meter. So if you want to find total charge, right, if you want to find total charge, so always what you will do, you will take some differential element, okay, some differential element. Suppose this is dl, So how much charge is distributed about this dl, right? So you can say the dl rho l times dl, right? Rho l times dl, okay? Rho l times dl will give you 1 minute. Okay, so you can consider a small segment, that is dl, right? A small element, differential element dl, having the dimension meter only, so this will give you dq, right? So if you want to find total charge, right, if you want to find, so you have got dq equal to what? Dq equal to, you have got rho l times dl, so you can compute, so integrate both sides, so you will get q equal to integration over the line rho l dot dl. Okay, this is the total charge, right? So you must know how to compute charges, total charge from the line charge density. I have told you that. Suppose this is a line, this kind of, and charges are distributed here, right? Charges are distributed and having the line charge density rho l, and rho l is basically what, the Coulomb per meter, right? And if someone is going to ask you what is the total charge, so what is total charge, you can consider one differential element, right? This part you can consider, right? And suppose this is dl, okay? So rho l times dl will give you what, dq, the differential charge. And if you want to find the charge which is distributed here, right, and the total charge can be computed by integrating both the sides, so this will give you q rho l and dl, right? Okay, so these things you might have studied in your school days in electrostatic. So this is the line charge, the story of line charge. The distribution of charge per unit length is called the line charge density and represented by rho L, okay, Coulomb per meter. Okay. If the rho L is constant, then it is uniform. Remember, if rho L is constant, okay, these are the important note, you have to keep this in mind, right? If rho L is constant, if rho L is constant, then it is uniform. Then it is uniform. Otherwise non-uniform, right? So having uniform charge density are impractical, remember, because suppose plus charges are distributed along the line, right? So they will what, they will repel each other, right? Because they same charges, okay, repel each other, unlike charges attract each other. So having uniform charge densities are impractical, right? You can write here, which is very important, having uniform charge densities are impractical, right? Okay, having uniform charge densities are impractical due to mutual repulsion, due to mutual repulsion, okay, between the like charges, between like charges. Okay, so having uniform charge densities are impractical, remember. So now I hope this is clear for everyone, how to compute total charge. Okay, right. Let's talk about surface charge. Okay, so surface charge, if the charges are distributed per unit area, right? So distribution of charge per unit area, here the distribution of charge per unit area. Okay, distribution of charge per unit area, distribution of charge per unit area, distribution of charge per unit area. Okay. So what is the how it is represented? That is rho s. Rho s, that is Coulomb per meter square. Okay, rho s. So suppose this is kind of a surface. Okay, and here the charges are distributed, right? You can say plus plus plus. Okay, so it has the surface charge density, right? This is known as the surface charge density. Surface charge density. Rho s. Coulomb per meter square. So if Coulomb per meter square is given, so how can you compute total charge? Okay, so what you have to do here is you have to consider some surface area, that is ds, differential surface area, and just multiply rho s times ds equal to dq. So total charge how can you compute? Q equal to integral over surface rho s ds. Well, this is how we compute, right? Remember. So ds having meter square, and this is Coulomb per meter square, so that gets cancelled and it gives you Coulomb total charge, and the volume charge density, distribution of charge per unit volume, distribution of charge per unit volume, right? Okay, represented by rho v, Coulomb per meter cube, Coulomb per meter cube. Okay, so volume charge density, it is known as volume charge density. And if you have got volume charge, then what you will do, you have to multiply with dv, so you will get dq, and total charge you can compute just by integrating, right? So over the volume, right? Rho v dot dv. Already we have seen this. Okay, so this is how we compute total charges. So in the examination they might ask this time, I think in the gate examination one question was there, right? So we must also know some important points regarding conductor, where the charges charge inside, note, you have to keep this in mind, very important. Charge inside the conductor is zero always, right? Charge inside the conductor is zero. Okay, as it, where does then the charge will be? If the charges are inside the conductor is zero, then charge will always reside on the surface, right? So as it resides on its surface, on its surface. Okay, this is what I wanted to discuss, right? Okay. And if I talk about how to find the distance between 2 points, suppose you have got they are the prerequisite I'm discussing, right? These are the prerequisite I'm discussing. So this is there are 2 points. Okay, suppose this point P1 is here, right? P1 is here and having the coordinate x1 by sorry, P1 is there and having the coordinate x by and z 1 1, right? 1 1 1. Okay, and there is a second point P2 here having x2 by 2 and z2. How to find the distance between these 2 points P2 and P1? So the distance between these 2 points will be you can suppose this is A and this is B. Okay, so BA will be what? BA will be, can be written as what? VAB can be written as x2 minus x1 along AX cap, right? So suppose this is R vector, right? So this can be written as what? X2 minus x1 AX cap by 2 minus by 1 A by cap plus Z2 minus Z1 AZ cap, right? And if you will take the magnitude of this R vector, so it will be under root x2 minus x1 square plus by 2 minus by 1. Already we know all these things, right? How to find the distance between two coordinates. Okay, because these things will be used to discuss the Coulomb's law, right? Okay. Now let's talk about very important law, that is Coulomb's law, right? Coulomb's law. So everything you have studied in the Coulomb's law, I mean in your physics, what is Coulomb's law? Okay. So what I'm going to tell you here is just I'm going to revise them, right? So where Coulomb's law is applied, remember always when the charges are it, okay. So charges must be at rest first, and this would be a point charge, right? This would be point charge. Okay, if they are a point charge, then we can apply Coulomb's law. Okay, and charges must be at rest. If charges are moving, then Coulomb's law will not hold. Okay, so these are the points which we need to understand. Okay, and Coulomb's law can be applied, inside the water, can be applied outside the water, right? If we are talking about Coulomb's law in the free space, okay, so we can discuss Coulomb's law in the free space, Coulomb's law where it has some dielectric constant, right? So I hope you might be familiar with dielectric constant and all. Okay, so let me write the definition, I mean the statement of Coulomb's law. Coulomb's law. What Coulomb says that, okay, so what does this basically give you? This gives force of attraction or repulsion between two charged, okay, remember, this gives, okay, force of attraction, force of attraction between force of attraction or repulsion between two charged conducting bodies, two charged conducting bodies, right? Conducting bodies. Okay, so if the charges are alike, okay, so there the force is repulsive, otherwise attractive. Okay, remember that if charges are alike, okay, then the force is, then the force is repulsive, okay, otherwise attractive. Okay, so Coulomb's law basically gives you the force of attraction, that's it. So you can compute force between two charges separated by the distance r, okay, line joining the distance r and all, right? So suppose these there is a charge q1 and there is a charge q2, right? And these are the point charges, line joining them, okay, and this r separated by the distance r, okay. the force will be in this direction, the force will be in this direction. It depends upon the polarity of a charge, right? Whether the charges are having same polarity, or so they will repel each other, right? So the what Coulomb says here, what Coulomb's made observation here is that whenever he put two charges near to each other, okay, at certain distance, what he observed was that the magnitude of the force between two charges he experienced, right? The magnitude of the two charges is proportional to the magnitude of the charge q1, the magnitude of the charge q2, right? And he also observed something, if these two charges are kept far, right, the force will be what? The force is gonna be less. Okay, if two charges are brought very close to each other, right, then the force is gonna be high. What he observed, right? So these are the observation made by the Coulomb. So the magnitude of F is proportional to 1 by r square. So if I combine the two, so the magnitude of force is proportional to q1 q2 upon r square, right? I'm just talking about magnitude. Okay, so this is the Coulomb's law basically, and force is having unit Newton. Okay, so if I open this proportionality sign, okay, so what will happen then? The the magnitude of the force is equal to 1 upon 4 pi epsilon. This is where you know where it is asked that where you are applying, where charges are there, I mean where the charge is kept, whether it is in the free space or inside the water or any different medium, right? So if it is equal to epsilon naught, F equal to 1 by 4 pi epsilon naught u1 u2 upon r square, mod of r square, you can say. It has the unit Newton. Okay, after all, force is a vector quantity, so it will be having, so either you can remove this naught, right, and you can say that epsilon is equal to basically, here epsilon is equal to basically what? Epsilon naught epsilon r, right? It has the unit farad per meter, so it is known as permittivity of the medium, or capacitivity, right? Kappa, because you can see the unit of this epsilon is epsilon is what? That is farad per meter. Capacity. Okay. What does it specify? Somebody will ask you, what does this guy? So you can say that this is K as well. That K. So K is basically what? 1 upon 4 pi epsilon. Now in the question they will mention whether you are in free space. If they did not mention about epsilon, so you can consider we are in the free space, right? So epsilon will be equal to epsilon naught, because this guy is relative permittivity. Okay, this epsilon r is what? The relative permittivity. Okay, right. So what does it specify? What does permittivity specify? Right? This is my question. So the permittivity specifies the property of a medium. Permittivity specifies the properties of the medium. Okay. Permittivities specify the permittivity of the medium, right? remember always, and that will indicate, and will indicate that will indicate what? The ability to store electrical energy. Ability to store electrical energy. Okay, so I'm not going into details, just I'm telling you what does it specify. So epsilon naught, if epsilon naught is what is the meaning of epsilon? Epsilon naught is the absolute permeability, absolute. Okay, this is known as absolute permittivity. Okay, absolute permittivity. Okay, VI okay. It has the value about 8.854 into 10 raised to power minus 12 farad per meter, or you can say that it has the value 10 raised to power minus 9 upon 36 pi, which we use in the calculations, right? Okay, so absolute permittivity, and epsilon r is basically known as relative permittivity. Relative, this is the permittivity for free space, and epsilon r is the relative permi double T I V I T Y, right? Relative permittivity. Okay, it has no units, remember, it has no units. Okay, this is very, very important. No unit. Or epsilon r is also known as the very important word, that is dielectric constant. Dielectric constant. Okay, so epsilon naught and epsilon r, these are very important. So if I talk about different material names, so alumina has epsilon r 8 to 9, so you can write some material name as well here, some material name. Okay, some material name, let me write, and I'm gonna write here some epsilon r values, right? So if I talk about alumina, so epsilon r is 8 to 9. In the question they will mention, right, where you are calculating the force between two charges. So if I talk about Teflon, right, Teflon fiberglass, Teflon fiber glass, right, so it has the 2.22. Paper honeycomb, if I talk, right, paper honeycomb, so it has 1.1, and the very important is the air. Okay, so air has epsilon r equal to 1. So it is also known as free space. Free space relative permittivity. Free space. Okay. Epsilon r in the free space. That is epsilon. Okay. So if we talk about force as a vector, right? So the force as a vector. So vector force acting on Q2 due to charge Q1 is given by what? So you can write here that F vector will be equal to what? 1 by 4 pi epsilon. Just keep epsilon only. Okay, if you are in free space, then epsilon naught, right? Q1, Q2 by R vector, okay, AR cap in general. And what is unit vector basically? Unit vector you can say is basically the vector upon the magnitude of vector, right? Unit vector is defined by the vector upon unit vector, magnitude of that vector. The vector R upon mod of that vector is will give you the unit vector, right? Okay. So this can be written further as the force F equal to 1 upon 4 pi. Okay, epsilon naught you can keep, or sometimes epsilon only. If epsilon is given, just okay, epsilon r is not given, then you can consider epsilon naught, right? And you know the value of epsilon naught, that is 10 raised to power minus 9 upon 36 q1 q2 upon r vector square dot r vector upon this. This is what in general you have to keep this in mind, right? So we'll solve few problems, so you will understand how we apply Coulomb's law. Very quickly we can do. Okay, so let me take one problem here. The problem says that very easy problem, right? Very easy. 4 point charges of a 10 Coulomb, okay, microcoulomb. We'll take one problem here. So 4 point charges. This is the Coulomb. If there are system of charges, there are two charges only, right? So the force between two charges is 1 by 4 pi epsilon naught, or epsilon q1 q2 upon r square. Okay, if there are system of charges, I mean there are, how we are going to compute what the forces, among all the charges. So the applies position, right? Superposition. So the 4 point charges each are located on x and y axes at plus minus 4 meter. Find the vector force on 1 millicoulomb, which is located at on the z-axis, on z-axis, at, at talk about minus 9 upon 10. So this question can be done very easily if you are able to visualize, right? If you are able to draw, I mean, it is located here, it is located here, it is located here, it is located here, and your next charge, that is 1 millicoulomb, where you have to find the force. So what you have to do here is you have to put one charge here, right? That is 1 millicoulomb, you can see here. 1 millicoulomb, which is located on z-axis. That force must be along this, right? The force must be along this, because only, right? This is also positive charge. This, so there should be a long x-axis, right, in the positive direction. Right? Uh, 10 micro coulomb you can say, 10 micro coulomb you can say, 10 10 micro coulomb you can say, and 10 micro coulomb you can say, right? So if I see the, because of this charge there is a force, in which direction it will be? It will be in this direction, right? So there charge force will the result force. The resultant force will be along z, right? So because this, if we will resolve this, okay, so horizontal component will be, you know, cancelled, only resultant force will be there, right? You can say that the overall force will be in the direction of az, right? Okay, so this is clear. Okay, now because of this x, okay, because of this this the force of attraction will repulsion will be there. Okay, so because of this the force will be like this. Okay, and because of this the force will be like this. Okay. What shall be the resultant again? The resultant will be in the az direction only, right? Because they are symmetrical charges kept symmetrically, right? So if the charges are kept symmetrically, the resultant will be in the direction of the z axis, right? I hope this is clear. Okay. Okay, so here it is in this direction, and this is, so resultant will be like this. Okay, so total four, so how many four charges are there? There are four charges. Okay, one, two, three. So the total force will be what? Total force will be 4 into total charge, product of these two, because 4 times the same force will be there. The same force will be there in the direction, you know, in the direction what? In the direction uh, this direction, in the az direction. So 4 times 3 1 millicoulomb into 10 microsecond. Okay, so what is that? Let me erase first this. Let me calculate the force because of one charge only. First, the force will be F equal to what? That is 10 into 1 millicoulomb, 10 coulomb into 1 millicoulomb, right? So that will give what? 10 into 10 raised to power minus 6, 10 raised to power minus 3 upon 4 pi into epsilon naught, that is minus 9 by 36 pi, right? So these things cancelled. Okay, just take 9 up. Okay, and this will get cancelled, so you will get 90. Okay, yes. So, but yeah, you forgot this, right? So there will be you know, 5 square, right? 5 square, because the distance you have to also see. This is 3. Okay, and this is kept at 4, right? So the 4, you know, distance you have to compute, right? So r will be 5 square, right? And times the vector upon the magnitude of the vector, right? So the vector will be what? Simple, that is going to be in the direction z, right? So direction z means 3 az cap upon the, and that is going to be 5. Resultant will be z. Okay. So let me keep here the same content. Okay, so the force is going to be what? The force will be equal to 10 into 9 upon 5 square into 4 times of 3 az cap upon 5. This will be the answer for this question. Why force is this 4 is coming, right? You have to keep in mind this 4 is coming because there are 4 charges, similar charges, right? And why AZ component is coming only, why AX and AY is not coming in the options, because they are charges are kept symmetrically. Okay, so important note here is, if charges are kept symmetrically, then consider the resultant force. Okay, I mean to say like this, charges are kept here, so what you have to do here is you have to consider resultant force. So what shall be the resultant force? Resultant force will be in this direction. This is the direction, right? Okay, so this will be the resultant. This and this cancelled, right? The charges are kept, okay, symmetrically. This is the concept I have applied, right? And if you're going to solve this question, okay, so how did I find this r square? Okay, so there might be confusion, right? So as we know that how to find the distance, okay, between 2 points, right? Suppose, let me tell you one. Okay, let me take this guy and here. Only one distance I'm going to compute, so you will understand. So this is kept at what? 0, 0, 3, and this is kept, suppose, at on the y-axis. This is 0 and I think 4 and and 0, right? Because we are on the y-axis, right? So in the y-axis, x0 and y0. So what is the distance between these? I mean, the force direction will be in this direction only, right? So r will, how can you compute r? R will be basically the this minus this, okay? So 0 minus that, so minus 4a by cap plus 3az cap. So you can see there is a minus 4a by plus 3z cap, and because of this, if I compute, so what you will get here? You will get again, so 4a by cap plus 3az cap. So you will get always positive 3az cap, but this is positive, this is negative. Once you will add this and this will get cancelled, right? So you will get resultant as this, 2 times of that. And because of x also, you will get here the same, okay, because of x also you will get same. Okay, so this r will be again will be minus 4ax cap plus 3az cap, and because of this r will be 4ax cap plus 3az cap. Once you will add all these vectors, so you will get only this, this, and this. That's why we have done 4 times 3z. And what is the magnitude of them? Magnitude will be 4 square plus 3 square, means 5, because this is 25. Okay. So if you know the concept, you can solve any question, right? So this is how we solve the question, and we'll meet in the next session, and we'll talk about various problems related to Coulomb's law. Then we will discuss electric field, one of the very important concept. Thank you so much for today. Okay, and we'll discuss about electric field, we'll discuss about D, we'll discuss about Gauss law and its application. Okay, so thank you so much for today. Please like and share these sessions among everyone, okay, so that they can be benefited. Thank you.